So once we have this agreement between the developer and the customer, that document we just talked about would become the legal contract. And not officially, but it pretty much is close enough to a legal contract that would describe what the developer promises to the customer. So once we have this document, we now move on to the next phase, which is program design, because now we know what needs to be done. So the program design phase is going to take care of how we're going to do this. How are we going to implement what we specified in the problem specification document? Now, there are a couple of approaches that we can use for this. So in a traditional sense, or a traditional programming approach, is we can use a divide and conquer strategy. Sometimes this is also called a top-down decomposition. So the idea with this is we take our tasks and we break them down into subtasks. And then these subtasks could be broken down into sub-subtasks and so on until each task is small enough that it's very easy to solve. Because you might have this one big task you need to solve and it just seems like it's way too much. But if you break it down into smaller and smaller parts, each part is a lot easier to work with, so you can take care of all the little parts, and then we can put those parts together to get the overall project. So these pieces would work together to accomplish the total complete job. There is a second approach, which is an object-oriented approach, and the idea with this is that we would have objects that we would identify, and we would determine the data and the subtasks that each of these objects would perform. So this would allow classes to be designed with variables to store the data and then the functions to carry out these tasks. And then the objects from these classes would cooperate to accomplish the job. So it's a similar approach to the divide and conquer strategy. And the whole point here is that the larger the project, the more important it is to think of the project in terms of the smaller building blocks or even the smaller classes, because otherwise you're going to get overwhelmed very easily. And then the result that we're going to get from this is the program design document. And this is going to break the problem down into subtasks and sub-subtasks and so forth, or even into the various classes. So some of this design may be documented graphically. So we might use like different types of charts or different diagrams to kind of give the properties and the functions of each class. We may have modules that would carry out the subtasks in a traditional design, or maybe even carry out some of the services that the objects would provide. But the whole point is that all these would be translated into separate sections of code. There must also be a complete specification for each module. What does that module do? What information it needs to know in order to do it, and what the rest of the program needs to get from that module when it's done. So this information must be sufficiently detailed so that a programmer can use the description as a guide when it comes to writing the code for the module in whatever language that they decide to use. Once the various tasks and subtasks have been identified, algorithms must be found to carry them out. Now, there could be several possible algorithms to solve a particular problem. So if that is the case, if there is a choice, then it must be determined which is more suitable for that particular task, or even perhaps what is more efficient. It may also be that an algorithm has to be developed from scratch. This too is a very creative process. So the documentation for this phase is going to include a description of the algorithms chosen or developed. Perhaps it could be written in pseudocode, and then an analysis of their efficiency and then the rationale for their use. Coding is the process of translating the detailed designs into computer code. Now, if the design was done correctly, if it was carefully developed, this should be a relatively routine job. And we might be able to use reusable code that can be pulled from a program library, or a useful class can be employed. So coding is the step that usually comes to mind when people think of software development, but as we've already talked about, there is a great deal of important preparatory work that precedes the actual production of code. Inexperienced programmers may think that they can just save time by skipping the earlier phases and just go right into coding, but the opposite is usually true. In all but most of the trivial of programs, tackling coding without first doing any problem specifications or any program designing or any type of algorithm selection or development usually leads to more time having to write code, more time being spent, and usually a poorer outcome. So if we don't do this design ahead of time properly, then this coding process is going to be quite tedious. Now, the coding phase would also result in a written document, and it's just going to be the code itself. Debugging is the process of locating and correcting program errors. Now, this can be a slow and expensive process that requires as much effort as writing the program in the first place. And there are several different types of errors, so I want to just introduce the three main types. So we have what are called syntax errors, which just simply means we didn't follow the syntax rules of the language. And we just failed to follow the correct rules of the syntax, which means that the statement is unrecognizable by the compiler, and it would result in an error. Now, these errors are irritating, but they usually come with messages from the compiler to help pinpoint the exact problem. Another type of error is what's called a runtime error, and this usually occurs only when the program is running and it's using a certain set of data that results in some illegal operation, such as dividing by 0. Did I mention you do not want to divide by 0? Just don't mess with that. Now, sometimes the software does provide messages to help detect the cause of runtime errors. And then the third type, and this is the most subtle type, which is called the logic error. These are actual errors in the algorithm itself. There's a problem with the algorithm because we don't get any syntax errors, so then it compiles properly. We don't get any runtime errors, so there's no messages there. But our output is not correct. We don't get the output that we intended. So this usually means that there are some incorrect steps in the algorithm, and it produces the wrong answers. So this is a very tedious one because you have to go back to your algorithm and figure out what actually went wrong. Now, I will mention that debugging is one of the most frustrating, agonizing, and time-consuming steps in the programming process. Just as anyone who has written code before, debugging is very annoying. And if you're spending a whole lot of time debugging, it usually means that you didn't really spend a whole lot of time carefully specifying, organizing, and structuring your solution. You didn't plan ahead of time, so now it's going to come back to bite you when it comes time to debugging. So if you've done all those steps ahead of time properly, then you shouldn't have as much debugging. I mean, don't get me wrong. I mean, no program is going to be perfect. You're very rarely ever going to write a program from start to finish and then compiles and runs and does exactly what you want it to do the first time around. So there's always going to be some debugging, but if you did the proper planning ahead of time, it shouldn't be that much debugging.